Oops, there's a backside. Oh well, guess we're going to have two movies. Use the graph in part A to draw an acceleration versus time graph for the motion represented above. Oh boy. So basically, the acceleration was -4, so the acceleration graph would look like this. It would be a straight line of -4, because the acceleration was always -4, because the slope of that line is always -4. Use the graph in part A to draw position versus time graph for the motion represented above. The position versus time graph will pass through the two dots plotted for you. Wow, this is tricky. Okay, so we know that we're going to want t and x for this graph, and we know that x equals 1/2 v0 plus vf times t. I think this is the way we want to get our data points. So we already know the times, 0, 1, 2, 3, 4. So the initial velocity is actually always 12. So x equals 1/2 times 12 plus v plus the final velocity times the time. So these are the two things we put in. So times 0, 0 times whatever is 0. Okay, well that one's already there. All right, so that's the first one. At time 1, we have 1, and the velocity at time 1 was 8. So this would be 1/2, 12 plus 8 times 1. That's 20, that's 10, that's 10. All right, so the next one, we are at 2 seconds and 4. So we would say x equals 1/2, 12 plus 4 times 2. So this would be 16. 8 times 2 is 16. 16. 16. All right, next we are at time 3 and 0 velocity. So we would go 1/2, 12 plus 0 times 3. So 12, that's 6. 6 times 3 is 18. So next we are at 4 and time 4, we're at -4. So we are at 1/2, 12 minus 4 times 4. So this would be 8. 4 times 1/2 is 2. 8 times 2 is 16. So that's the point. They said we would be at 18 here, and we are. So now we go at time 1, we're at 10. So this is 6. What's this? 3, 6, 9, 10, 11. So 10 is somewhere around here. 2 is at 16. So this is 12. 3, 6, 9, 12, 15. So 16 is right here. And then at 4, we're also right here. So our position would look like this.